Good morning everybody. In this video, we shall discuss about the introduction to Fourier series and their related formulas and a simple problem based on this result. So first the formula for Fourier series is given by f of x in minus pi comma pi open interval. F of x is equal to a naught divided by 2 plus summation n equal to 1 to infinity a n cos nx plus b n sin nx, where a naught is equal to 1 by pi integral minus pi to pi f of x dx, a n equal to 1 by pi integral minus pi to pi f of x cos nx dx, b n equal to 1 by pi integral minus pi to pi f of x sin nx dx. And we have to know what is the odd function and even function in Fourier series to solve the simple problem in a simple manner. So even function, so when f of minus x is equal to f of x, then f of x is said to be even function. Example, cos x, that is in f of x, in the place of x, if we substitute minus x, if we get the same f of x, then the function is said to be even function, because cos x, instead of x, if we substitute minus x, cos of minus x, so that is the same cos x. So f of minus x and f of x, both of them are equal, so cos x is an even function. So for odd function, if f of minus x is equal to minus f of x, then f of x is said to be odd function, sin x, because sin of minus x is equal to minus sin x, that is minus f of x. So sin x is an odd function. Let us see the simple problem. Obtain the Fourier series of for the function f of x is equal to x square in minus pi comma pi, and deduce the sum of the series for the two series they have given. Solution, f of x, I have written the formula as I given in the introduction, and to know whether the f of x is odd or even function, I am substituting in the place of x minus x. So f of minus x is equal to minus x the whole square, that is the same x square, that is same f of x. So it is said to be even function. In even function, bn does not exist because it has sign related terms. So sin is an odd function, so bn does not exist, and formula for Fourier series also is reduced to a naught by 2 plus summation n equal to 1 to infinity a n cos nx alone. So a naught formula we have known, 1 by pi integral minus pi to pi f of x dx. So instead of f of x, I have substituted x square and integrating them in the interval minus pi to pi, getting the answer as 2 pi square by 3. So f of x is equal to that formula I have written, bn does not exist, so I have deleted that. An is nothing but 2 by pi integral 0 to pi f of x cos nx dx, because the function is even function. So instead of minus pi to pi, I can write 2 by pi integral 0 to pi, and instead of f of x, I have substituted as x square, and using Bernoulli's formula, integral u dv equal to uv minus u dash v1 plus u double dash v2, getting u equal to x square. So u dash is nothing but 2x, and u double dash, again differentiating and getting as 2. dv is nothing but cos nx dx. So integrating them, we will get v, and again going on integrating, we get the value for v1 and v2, and an 2 by, in the an formula, the integration part, I am applying the Bernoulli's result. I can, the interval is 0 to pi. So sin pi is also 0, sin 0 is also 0. Sin any pi is 0, sin 0 is 0. So I can take 2x cos nx by n square alone. I can delete the first and third term. And applying the limit, I will be getting a 4 by n square cos n pi. So cos n pi is nothing but minus 1 whole power n. So in that Fourier series formula, I am substituting the value for a naught and an. So I may getting pi square by 3, and the summation terms, that is n equal to 1, 2, 3 up to infinity, we have to add them. So minus 1 whole power 1 by 1 square cos 1x plus minus 1 whole power 2 by 2 square cos 2x, etc. And to deduce the result for the two series, I have to substitute x is equal to pi on both sides. So pi square equal to pi square by 3, like that I have substituted. Cos odd pi is minus 1 and cos even pi is plus 1. So based on this result and rearranging the pi square by 3 term to left side, I will be getting 4 into 1 by 1 square plus 1 by 2 square plus 1 by 3 square. So if I take 1 by 1 square plus 1 by 2 square plus 1 by 3 square outside, I will be getting pi square by 6. This is the result for the first one, what they have asked in the question. And to deduce the result for second one, I have to substitute x is equal to 0. Cos 0 value is 1, and we can take pi square by 3 to the left side. I will be getting the value as 1 by 1 square. To get the value, I have to take once again minus 4 as common in the right side, and I will be getting the final result 1 by 1 square minus 1 by 2 square plus 1 by 3 square equal to pi square by 12. That's all this problem. Thank you.